Did I? I don't know. I just know the process. Okay, so number one, the whole goal is to get the same base. If you can't get the same base, you have to use a logarithm. We'll work on that next week. So, I mean, it's kind of pretty lucky that both of these are a power of 4, right? Like, how many equations in life do we think both bases will be power of 4? It's great when it happens, but when it doesn't, mathematicians have figured out a different way, and that's called a logarithm. So that's next week. So I did thinking powers of 4. You could have also done powers of 2. I don't think 256 is the power of 8, is it? No. Did anybody do a power of 2 on both sides? Oh, okay, good job. How? Well, I believe 2 to the 6 is 64. Yes. So 2 to the 8 is 256? Yes. 8 is 256. But I would think most people would go with the power of 4. 4 to the 3rd is 64. 4 to the 4th is 256. So I'm going to do it with the 4. So I'm going to take 64 out and I'm going to put 4 to the 3rd in. And I'm going to take 256 out and put 4 to the 4th in. Who was absent yesterday? Okay. So we're just replacing this big number with a smaller number and an exponent. Step 2 is to distribute your exponent. And then once you get the same base on both sides, you can equate exponents, which sometimes we say drop the base, but really what we're doing is just setting the exponents equal to each other. That's a property of equality. Jacob, how'd it go? Still got 12? I'm 24 divided by 4. So even with base 2, there's a couple of students in the room who did the base 2. They ended up with the same answer. Max, how'd it go? What was your answer, Max? You said you did it.
Oh, number 1?
Yeah, number 1.
Oh, number 1 is -4.
Take a look at that.
Oh,
My first guess is that you didn't fully distribute on one of these. Look at your exponents. Do you have a 24 here?
oh yeah, I forgot.
Did you do 24 here?
Yeah, I did 24.
Okay, so a lot of times we just forget to distribute all the way through. Okay, so I have a tip for you for fractions. That's the tip. Fractions, you want to consider negative exponents. Yes, that's sounding right. So 3 to the 3rd is 27. Hopefully that's something you're comfortable with now. At the beginning of the year, I wouldn't have thought so, but we've been doing, quite a lot with different powers. 3 to the negative 3rd then is 1 over 27, because negative exponents are just reciprocals. So this is a pretty big tip that you need to write down. And so I have some fractions in your assignment today so you guys can practice that. Remembering to think of negative exponents. So we're going to take 1/27th out. And we're going to put 3 to the negative third in. We'll take 9 out and put 3 squared in. Joanna, what's the next step? Yeah, really good. Really good. What would I do next here? I'm going to go walk around.
Right there?
Yeah.
I gotta subtract. Nah, since it's the same base, you gotta put the negative 9x equals 39 equals 10x minus 1.
Yeah, you got to
And then you
equate
solve it.
exponents.
And then from there, I'll do the negative 9 first. I think I'm wrong though.
No, you're right.
I'm right?
Yeah,
Okay,
you're
then
right.
I'll add the negative 9x to the 10x, which is 19x. Now it'll be set up as negative 39. 19x. Then you add the 1 to the other side. Or, no, am I wrong?
You're right.
Oh, yeah.
Our answer's going to be a fraction.
Then you do 38 equals
38.
19x, and then I don't know what that is. But whatever that is that 9 fraction now?
Actually, it divides evenly.
Where'd you get the 4?
I guess so.
See, I know how to do it. That's why I'm doing it.
What? What out of 4? 40? Did you have 40? What half times what half is 40? Okay, let's look at those 6 problems you did in your workbook yesterday. Take note, I don't know. Cultural somebody. Most of us are fortunate because we didn't I lost 3 of them. Yum. Alright guys, we're gonna today we are going to, you know what, keep your workbooks open and it's still open. I'm gonna do number no, I better not.
Wait, Miss Gladys, did you get my work?
Yes,
What?
yeah, I better. Hey, we're gonna do number 13 right now in here.
Miss Baldwin, when are the project grades gonna go in?
I don't know, maybe Sunday. Maybe not. We'll see. The weekend is set off.
I hope your weekend's really boring, so you like wanted to work for fun.
Oh, so nice.
Yeah. Because I know I ate that up, but I just wanna know how well I did. I know I did.
Did you do George Cantor?
Huh?
Did you do George Cantor?
She's talking about the credit card.
No, mine's right there actually.
Dobby did you know the work?
Alright, so today I'm going to teach you this part, writing an equation. So notice these are answers that are equations. So writing an equation given 2 points.
Wait, what?
And we're going to do some word problems. So I was just going to start with word problems, but I decided to start with this instead. So, all we have is 2 points. 0, 3, and 3, 375, and we're told to write an exponential function. So what else we have, which I haven't really talked a lot about, is this form y equals a times b to the x. This is like the model for an exponential function. If it was growth, then the base would be 1 plus and all that, but this is like the basic model. And if you're told it's an exponential function, you can rely on this model. So the a is always the initial amount, right? That holds true to like our credit card problems and our word problems we did. So that initial amount is also the y-intercept. So it's also the point. It's also the point where x is 0. Because if I put a 0 in for x, anything to the 0 power is 1. It would be a times 1. So, and then x and y are just ordered pairs like they always are in any problem. So if you look at these problems in your workbook, you'll see that they all provide you with the y-intercept. They have this 0, 0, 0, 0, 0. So that means that this 3 is the y-intercept or the initial amount. So I'm going to plug 3 in for a. So if you want to write a step down, you plug in the y-intercept for a, which is the initial amount. When x is 0, y is 3. Yes? No, because it's not a straight line. That formula won't work. You find b by doing a ratio. Oh, man. Okay, so step 2 is just to plug in x and y. Plug in x and y of the second point. So moving forward to step 2 also. So this is our second point. Y is 375. I'll label this on here for you. That's A. That goes in the X spot. And that goes in the Y spot. So it helps if you write the model down every time. So we got 375 equals 3 times the base. We aren't told. We aren't told the relationship here.
Wait, where did you get 375?
The second point.
Oh.
This X and this Y get plugged in for X and Y. And now we can solve. So step 3 is to solve. No, I didn't. So I'll put a line here. I'm trying to find B, so I'll divide by 3 on both sides. 125.
That's like I came for you.
And what's the last step here? Yeah. Cube root both sides. And now we know the base is 5. I'll put one more step in. The directions were to write the equation. The equation has A and B. So my equation is y equals 3 times 5 to the x. It's like a system. We're going to do a couple word problems right now in your notebook. So I just want to show you this is an easier one compared to the word problem. So in your notebook, let's do a word problem. No, but yeah. You have a question about this work here? No. Population. The way population changes is typically modeled with the exponential function. So in 2000, the population of Phoenix, where's Phoenix? Arizona, was 1,321,045. Has anybody been there? You've been there. What do you think? It was hot. By 2007, it was estimated at 1,512,986. Write an exponential function that could be used to model the population of Phoenix. X is the number of years since 2000. So this, you need a calculator. So have your calculators ready. It's the same steps as these two ordered pairs. So let's think about this data as ordered pairs. Should probably turn that down. All right, in year 0, so we're starting in year 2000. That's considered year 0. We're at 1,321,000. 7 years later, 1,512,000. So this is our data, thinking about them as ordered pairs. And this is our model for exponential functions. So keep in mind that wherever the 0 is your initial amount. So our initial population is here. Initial population goes in the A spot. So I'm at y equals 1,321,045 times the base. We don't know the growth factor. That's what we're searching for, is by what percent did the population grow? Put an X there. Okay, so same steps. We plugged in the y-intercept for A. Now we're going to use the second point. 7 is our x, and 1,500,000, so forth, is our y. Are we good? We're good? We're good? Okay, Autumn, what's my next step here? I'm on step 3. Yes, so we're trying to get this letter along. Good job. This is multiplication. We'll do the opposite of multiplication and divide. Jackson, you got a calculator ready? Because I don't. So I'll get one. I'm gonna go 3 in. But I'm not gonna cut this number off in my calculator. This is still in my calculator. Holding in my calculator. Jackson, how do I go from here? We have to somehow get this b alone. We need the exponent gone. How do we cancel out something to the 7th power? 7th root it. We are 7th rooting. We'll do a 7th root here and a 7th root here. So that's, you gotta find a calculator. Do that. And I'm gonna pull in my exact decimal. Yours might be different than me. This is so good. This is full circle. I got 1.0195. So that's gotta go to 10. So that's gotta go to 2. Were you able to pull in the exact decimal? Did anybody just put the 7th root? Does anybody need help 7th rooting? Yeah. Hit the that first, and then go second. That. Did you guys get 1.7?
This button, right? Yo hablas inglés.
You should just do, and then self-reading, 625, you should apply.
So why you round it up to 1 point? Oh,
This is not the answer. Some people will stop here. You did a lot of work. You did great. It's not the answer. The answer is 1,000,000. Nice. So here's my question for you guys. By what percent did the population of Phoenix grow between 2000 and 2007? Torian? 2%. Remember, this is the growth factor. This is 1 plus rate in here. So this population grew 2%. When you calculate B, you're given a lot of information about the data. That represents a 2% growth. If it was less than 1, then you would have to think about, subtracting 1, how much it was decaying by. About the growth rate, I definitely will. I want you to understand 1 point something. That point something is the rate that was added to it. And then it's also definitely like SAT type question here. No, they're gonna say how many years until the population reaches 3 million. Yes. We're gonna do that next week, maybe 2 weeks. All right, last one. Then you guys can start your assignment. 20%? 20%. Whatever your grade is right now, that's 20%. You have no idea how to do this problem.
Yes, I do.
How do you start it?
Okay, like you just did up there. You put the ring on top, and then I don't know how to explain, but I know how to do it.
Go ahead.
In my own words.
Look at your data as ordered pair. Then you apply the model.
A fraction? Okay. I've been doing this wrong the whole time. Look. Even for this one.
That's the initial amount that's Y.
Yeah.
And then it's 34 times C, and then that number is what you're splitting. So like that's X, so it's Y. So basically it's Y.
Oh.
And 2 is X.
Okay, so what am I dividing?
Number.
Did it give you 20? Oh wait, didn't I have to split it?
Yeah. So I did 3 last time, right? Yeah, let's stick with thousandths. Okay, what was happening in Tinsdale? Tinsdale. Isn't it Tinsdale? The place in Arizona?
I don't know.
I'm making that up.
I'm
I'm making that up. What's the growth rate? 9.6%. So the population there is growing much more quickly than it is in Phoenix. It probably has more land. So the growth rate is the number after 1. Because it was 1 plus something that led to the. They call it a growth factor. You always say what? We could have put T there. Is that what you're saying? We could have put a T there. But so it's saying oh, we didn't even stop yet. We haven't even stopped it. It's saying solve in 2012. So now we're gonna put a 12 in here to figure out is it A, B, C, or D. Oh. It's A, 28,411, but my number's coming out 28,317. That's due to our rounding. When I use the entire decimal, I got 28,414, which is much closer to that. So that's rounded a little bit different as well. For your homework, round to the thousandth, and I'll take your answers. Okay, let's get started on your workbook. You probably still have questions, so I'll start it with you. If you want me to start on the starter formula, you let me know.
Wait, I did this one. I have to minus the 56. I can't do this one because it has. Is that right? I'll read that.
No. Is it 10 minutes?
No, we're good.
Okay, go. Sorry. Ready, Alexa? You should start on page 94, number 5. The same as 3 through 10. Do you guys want me to start on like 3, or should we start on a more difficult one? The most difficult one there is.
Start on 3.
Or easy.
I don't understand this.
Boy.
What's 3 then, Hugo?
What? I got 36.
You got 60.
What did you do first?
Well, I did
Oh my god.
3 to the square root of 1, and then 3 to the square root of 2. And then I just distributed. And I saw.
Why would you do that?
Oh, yeah, 2 to the third. So it's S minus 1 plus 6.
Yeah. So it'd be 60. Or negative 60. Negative 60.
Exactly. Did you have to subtract the 2 then? Oh, yeah, it's x equals negative 60.
Bro. Easy. You got it wrong.
Yeah, I thought it was. What?
At least it was easy.
Oh, I did. That's like
Oh, you did do it.
I did, but I'm gonna wait for it.
Wait, can you do number 4?
Yeah, let's do it.
Because I already did 7, 8, 9, 10. Yeah. Just a little bit confusing at the beginning, but I'm good now.
How about that?
Wait, I did 2 to the negative 2. That's still working now.
Yeah, I think it's 2 to the 6th then. 64. 2 to the 5th is 32. So with 4, you can use 4 and go to 2. You get the same answer either way. But fractions require negative exponents.
Well, isn't the x value of the second coordinates, isn't that the x value?
Yeah, exponent.
X. Yeah.
Oh, wait, no. Sorry. Yeah, sorry. I forgot to change the 5. Then you still divide by 5.
What?
Just 1/5. Yeah, that's fine. What's 95? Oh, 94, 94. It's 94. Did anybody not get 1/5? Did you know now? Did you do this one yet, Tori? Number 4?
Yeah.
You got 1/5? Okay. What an interesting answer.